The following is an overview of the Leviton Series 6000 panel meter, which includes a review of the key features and brief overviews of how to use it for a variety of common scenarios. The Series 6000 panel meter can be used in a variety of applications. OEM panel shops and their switchgear customers may find it an attractive option for integration into switchgear. In industrial applications, it is a good fit for motor control and process control centers. It is manufactured in an industry-standard panel mount form factor. This meter provides a very complete data set, including power quality metrics. The Leviton Series 6000 family includes a full range of split-core and Rogowski current transformers. Leviton offers three models in the Series 6000 meter family. 60P00 is a Modbus RS485 only model. 61P00 includes both Modbus RS485 and BACnet IP interfaces. 62P00 is a special order item with a Profibus interface. This model has minimum order quantities and is stocked. As you can see, the front panel features a large backlit LCD with a capacitive touchscreen button interface. The meter supports the typical electrical service types up to 480 volts AC and automatically detects the voltage. It does have separate control voltage inputs, so it can continue to operate even if the circuit being monitored is powered down. There are three user-configurable digital or analog inputs which may be used in a variety of ways. There are also two user-configurable digital or analog outputs which, when combined with the alarm's functionality, can provide a variety of control functions. The 61P00 Ethernet-enabled model. This type of meter is frequently used to monitor industrial power distribution equipment, similar to the application shown. They may be installed by the OEM panel builder as part of the panel gear or as an upgrade to equipment in the field. Either way, this family of meters should be an attractive option when metering is needed. A Series 6000 meter system requires the following components: 60P00 Modbus RTU and 61P00 BACnet IP meters, CTs which are sold separately based on need. CT cables are required to connect the CTs to the meter. These come in several lengths: 1 meter and 2 meter cable kits with 3 color-coded cables or 5 meter and 10 meter individual cables. Next, let's review the core monitoring and reporting features of the 61P00 meter with its integrated WebView software interface. Logging into the meter's WebView interface using the meter's IP address is an easy way to review and download data directly from the meter. This initial summary screen provides a quick summary view with several of the key parameters in both graphic and tabular form. For users who want to see a live dashboard view of the meter, this could be an ideal view. The UI view offers a quick view of the live readings on each phase, which may be set to show either an instantaneous or average reading. Selecting the I view will display the current in amps. This view is helpful to confirm that there has been no phase loss and the load is balanced across the phases. Selecting the U view displays the voltage for each phase, which again can be set as either an instantaneous or average reading. In this view, the voltage for each phase should be stable and very close to the same value on each phase. Voltage swells and sags would show up in this view. Selecting the Power tab converts to active readings for several additional parameters. The P view shows power in kilowatts. Another important power quality metric is power factor. Selecting the PF view will display the power factor readings, which in a healthy system will be near 1.0. This reading is for all three phases combined. Switching up to the Trends view will display the historical data stored in the meter. The meter has sufficient data storage to keep 1 year of data for the 12 user-selected data points. As with the other screens, selecting the options across the left will update the display with the following values. I displays the average current over time. U displays the average voltage over time. P displays the average watts over time. Q displays the average volt amps reactive over time. S displays the average volt amps over time. The scaling of the data graphs on these windows is adjustable. Clicking on the Scale Auto Adjust button will zoom in on the y-axis of the display to help highlight any changes in the readings. On the right-hand side of the window are the X-axis scaling buttons, allowing the user to zoom in and out on the timescale being displayed. Zooming in using the 2x and 4x buttons will drill down on the selected area, showing much more detail for a shorter time frame. This can be an easy way to identify anomalies in the data and zoom in on them to get a much more detailed view of the event. The WebView tool also supports downloading the trend data into a CSV file. Clicking on the small report icon in the upper right-hand corner of the window will execute the export function. Any of the trend data screens with this icon shown can be exported. It is easy to create a multi-window dashboard view using a group of WebView windows arranged on the screen. Different views of the various metrics or several different meters may be shown simultaneously by opening a new browser window for each view. The CSV file download will provide the timestamp data for the selected parameters. This data can be utilized either in spreadsheet form or uploaded into a database for use with other analytics software. This is a simple example utilizing the CSV data in a table in Excel. The data table was used to generate a pivot table and graph to show the voltage by phase over time. The graph is an easy way to utilize the data and makes it easy to spot anomalies. In this example, slicers were used to help filter the data and isolate any specific points to be analyzed. In similar fashion, this table and graph were created from the amperage data over time. It is easy to spot the spikes in the values in the graph, which can then clearly identify a time frame and scope for further analysis. This is a quick overview of the key features of the alarm monitoring and reporting features of the Leviton Series 6000 meters. It is not a comprehensive guide, but it should provide enough detail to help get started with configuring and monitoring alarms. Series 6000 meters have a very powerful and sophisticated set of alarm functions. Alarms can be generated when a threshold is exceeded for the electrical measurements, consumption, and variations in level or change in input status. Also, combinations of alarms may be used to create logic for triggering meter outputs. The EasyConfig software is used to configure these alarm settings. The alarms may utilize a variety of the measured parameters with high and low thresholds as well as time delays for triggering and releasing the alarm. THD, voltage, and current alarms may also be configured to consider triggers on any single phase, all three together, or only one of the three phases. Please refer to Section 10 of the user manual for more details. This is a quick view of the alarm's configuration screen in the EasyConfig system software. As you can see from the alarms menu on the left, there are several different alarm configuration options. We won't go over all of these in the overview, but focusing on some of the most common options will illustrate these powerful features. The measurement alarms are the most commonly used type, where the alarm is monitoring designated parameters from the meter. As you can see from the screenshot, there are several configuration parameters to fine-tune the functionality. The alarm must be enabled and given a descriptive name. If appropriate, determine which phase or phases are being monitored. Determine whether a notification will be automatically triggered. Define the output if one of the meter outputs is to be triggered by the alarm. Assign the high and low threshold for the alarm parameter. Referring back to Section 10 of the user manual, there are descriptions of several of these more common configurations. 10.1.2 outlines voltage and current imbalances. 10.1.3 covers EN50160 voltage quality events. 10.1.4 describes monitoring for excessive consumption values. 10.1.5 describes the options for how to utilize the digital inputs in alarms logic. Not only are there individual alarms for voltage and current events, the Series 6000 meters also support combination alarms. This is a very powerful way to create logical alarm functions based on several independent parameters. Selecting the combination alarm option opens another alarm configuration screen. Up to 4 of these combination alarms may be created, and each with different values and logic applied. As you can see, this could be used in a variety of ways depending on the application. Again, there are lots of additional details in Section 10 of the user manual. If the alarms function is useful, you should explore these options and take advantage of these advanced capabilities. Let's take a deeper dive into configuring the EN50160 alarm to monitor swells, dips, and interruptions in service. Open the Easy Config software and select the appropriate meter. From the Device Configuration menu, select Alarms/EN50160 Alarm. In the EN50160 alarm settings, enable each of the alarm functions. Alarm 1, Swell Monitor. Alarm 2, Dip Monitor. Alarm 3, Interruption Monitor. Each alarm has configuration options for the following: criticality, used to sort and filter reports; output, used to select the meter digital outputs 1 or 2 if the alarm is used to trigger some external device or system; delay, typically left at 0. This would be used to set a time frame for the alarm condition to assure it remains in the alarm state for a specified time before triggering. The delay is specified in seconds. Each alarm can be configured to trigger when any of the 3 phases, 1, 2, or 3, exceed the threshold. Now let's take a closer look at configuring the traditional measurement alarms. There are 9 user-configurable measurement alarms available. These can be configured to monitor a variety of different parameters. Each measurement alarm will need to be enabled for use and configured. The list of parameters which can be monitored is extensive. These include voltage, current, THD, power factor for individual phases, or as a system total. See Section 13 in the User Manual for a list of the various parameters that can be used with their function. Each alarm can be configured to trigger when a single specified phase, all 3 phases, or any of the 3 phases individually exceed the threshold. Each alarm has configuration options for the following: criticality, which is used to sort and filter reports; output, selects the meter digital output 1 or 2 if the alarm is used to trigger some external device or system. Threshold values need to be set to the high and low values appropriate for the alarm triggers. Hysteresis may be used to compensate for a typical fluctuation in the measured parameters to avoid false triggers. Hysteresis is applied as a percentage of the value being measured. Delay is typically left at 0. This would be used to set a time frame for the alarm condition to assure that it remains in the alarm state for a specified time before triggering. The delay is specified in seconds. With all the parameters configured, click on the Program button in the upper right corner to send the settings to the meter. After programming, both the value and the meter display columns should match, indicating that the meter has accepted the updates. As alarms are triggered, they are logged in the meter for reporting. This section covers the reporting features of the 61P00 Ethernet-enabled model and its embedded WebView software. Using your browser, log into WebView using the IP address of the meter. For the purpose of alarms reporting, we will focus on the Alarms and Events section. This is the main Alarms and Events display page. The In Progress tab shows any alarms or events which are still active. The filter settings are used to narrow the list to the items desired. Active alarms will be displayed until the alarm condition is resolved. Clicking the magnifying glass opens the detail screen. This shows the status of the element at the time of the alarm event. A history of alarm events will be logged in the Finished section, which is available for download from the meter. Clicking the magnifying glass opens the detail screen. This window presents all the details captured for the selected alarm event. Clicking the Report Download icon opens the Report Download detail screen. Set the starting and ending dates to the appropriate date range. Note: if the date is too broad, the report could time out and fail. Click OK to execute the download to a CSV file. This downloads all the alarm and event activity into a file, which can be sorted and filtered as needed for reporting. This section covers the built-in load shedding feature of the Series 6000 meter, which is managed using the Easy Config software tool. Open the Easy Config software and click on the plus button at the bottom of the screen to add a new meter. Fill in each of the fields in the new meter configuration window and click the check button to accept the entry. With the meter showing in the list of connected devices, confirm that the blue slider switch at the right side of the screen is on, indicating the meter is connected and working properly. Click on the checkbox next to the name to select it for editing. From the main device's configuration screen, click on the wrench icon on the left-hand toolbar. Under the configuration menu, select Load Shedding. In the Load Shedding Setup window, fill in the various load shedding values for each field. Next, select the Digital Output option from the configuration menu. Then enter the values in the Digital Output window to set the type and mode settings. With all the values entered, click the Program button in the upper right corner of the screen to send the settings to the meter. Returning to the main Easy Config menu, select the Logical Output option. This will display the Logical Output status window showing the meter's outputs. As the meter sees value outside the threshold values for the load shed alarm, the output state of the meter will change from activated to deactivated. Whatever external devices is tied to this alarm output will also see this change of state, indicating the load shed action.